In the realm of science and tremendous secrets, the question of what existed before the massive blast has sparked mixed discussions and fascinated thinkers for a long time. This enormous inquiry doesn't simply test how we interpret the universe. It challenges the very limits of human understanding. Imagine standing at the edge of existence, peering into the great unknown, and pondering what lay there before our universe came into being. The event of the Big Bang marked the dawn of space, time, and everything we know. But was there a moment before this? Could there have been a state of nothingness, a silence before the cosmic symphony began? If so, what was it? Or perhaps there was something even more profound and disturbing that existed before time itself. As we delve deeper into this question, science takes us on a journey beyond the universe's starting point, into speculations that challenge our very consciousness. Physicist Brian Cox, known for his investigations into the marvels of the universe, suggests that something astounding could have existed before the Big Bang. He challenges us to rethink our notions of reality and existence. In this exploration, we'll dissect the science, theories, and stunning mysteries that may explain what preceded everything. We'll explore concepts such as cosmic inflation, quantum fluctuations, dark energy, and even multiverses. The answers we uncover might shock you, but they could also open new understandings of our place in the universe. Prepare to dive deep into a world beyond imagination, a science where the unknown still lurks in the shadows, leaving scientists amazed and sometimes even unsettled. Let's explore what existed before the Big Bang and why these theories challenge everything we thought we knew. To appreciate what might have existed before the Big Bang, we first need to understand what the Big Bang actually was. As scientists define it, the Big Bang refers to the moment when the universe became incredibly hot and dense, rapidly expanding to trigger the development of all matter, energy, and the fundamental forces. When we look toward the night sky, we see evidence of this hot beginning, with galaxies spreading out from an initial point. But why did this happen? And was there a time before this dense, hot origin? According to the theory of cosmic inflation, there was indeed a before, and it was far from empty or serene. Cosmic inflation suggests that before the Big Bang, the universe was in a state that was cold, empty, and free, essentially like a massive vacuum. However, this vacuum wasn't truly empty. It contained an immense amount of energy that fueled the rapid expansion of space itself. This expansion, called inflation, occurred so quickly that it laid the groundwork for everything that would follow. In a fraction of a second, space stretched at unimaginable rates until inflation slowed down, and the energy transformed into matter, particles, and the forces we observe today as the Big Bang. But what was the nature of this energy? Why did it suddenly expand the universe? And why did it stop? Scientists believe that this boundless expansion created patches of the universe, each experiencing its own Big Bang. Imagine a fabric stretching endlessly with small bubbles forming here and there, each bubble representing a universe, including our own. This idea, called the inflationary multiverse, suggests there could be countless Big Bangs and a limitless number of universes. Ours is merely one of many. This vast, mind-bending reality challenges our understanding of the very nature of the universe and leaves us with the question: what else is out there? The idea of nothingness before the Big Bang is speculative, not factual, at least according to our current understanding. Even if you were to remove all energy, particles, and radiation from the universe, it would still not be truly empty. Our universe is filled with dark matter, dark energy, quantum fields, and various forces that weave an interconnected fabric, even in its most barren state. Even if we imagine stripping away these forces, leaving a dead space, the universe would still generate new forms of energy. This fact alone confounds scientists, as it suggests that true nothingness may be impossible within our infinite cosmos. Space itself has properties, rules, and constants that prevent it from being entirely empty. For example, there's a phenomenon called zero-point energy, which represents the lowest possible energy state of quantum fields. In this state, particles can still briefly appear and vanish, creating a ghostly echo of activity even in what should be empty space. This challenges our idea of a true void and suggests that, yes, even before the Big Bang, there was something that scientists are only beginning to comprehend. One of the most fascinating theories in modern cosmology is the possibility of eternal inflation. If inflation could create our universe, it's possible it could continue forever. Physicist Brian Cox describes an astonishingly vast inflationary multiverse where universes are endlessly created and keep expanding. Imagine each Big Bang as a spark igniting another universe while inflation continues in other regions, creating countless other universes. This process could, in theory, happen infinitely. This idea of infinite universes leads to the concept of a fractal universe, where each new universe could trigger its own Big Bang. Each universe exists as a separate, independent region, unaffected by the others due to the rapid expansion of space. For researchers, this hypothesis is both thrilling and unsettling, as it suggests a ceaseless multiverse with no definitive beginning or end. Imagine our universe as just a tiny speck in a vast cosmic structure, eternally expanding and constantly creating new universes. And what if the unsettling truth is that there is no before or after, but rather a timeless pattern of universes forming and dissolving? Our understanding of nothingness shifts when we consider quantum field theory. According to this theory, the universe isn't just a collection of matter floating in space. It's a complex network of energy fields that fill the universe and interact to create everything we observe. These fields are like invisible oceans, with particles acting as waves or disturbances. Even when fields are at their lowest energy level, the vacuum state, they are still active. Particles can appear and disappear in these fields momentarily, borrowing energy before vanishing. This phenomenon results in the existence of virtual particles, substances that briefly exist and then fade away, leaving only a faint memory of their presence. The concept of virtual particles challenges the idea of true emptiness. Even in an empty universe where all matter, radiation, and energy are removed, the fields remain active, sometimes creating temporary particles. This constant activity in what should be nothing suggests that the universe doesn't recognize our concept of emptiness. Instead, these fields and forces persist, filling the universe with hidden energy that prevents absolute nothingness. This raises an intriguing question. If fields create particles and particles create matter, could the universe itself have emerged from this nothingness filled with quantum fields? Dark energy is another mysterious force that currently drives the accelerated expansion of our universe. But did dark energy exist before the Big Bang? Some theories propose that dark energy is a remnant of an energy field that existed before our universe's formation. Its properties seem to suggest a hidden, immense force that could have been present in some form before the Big Bang. In a stronger state, dark energy might have powered the inflationary phase, causing rapid expansion. The presence of dark energy implies that even if our universe were drained of all matter and radiation, this force would continue to stretch the fabric of spacetime. This idea leads to a disturbing question. If dark energy existed before the Big Bang, could it have created the conditions that led to the birth of our universe? Could dark energy be the silent architect of inflation, or even the true origin of our universe? As we explore this possibility, we confront the idea of dark energy as not only a force shaping our universe, but also a key that might unlock the secrets of the multiverse itself. Another theory offering an alternative to the Big Bang as the ultimate beginning is cyclic cosmology. The idea that the universe goes through infinite cycles of birth, death, and rebirth. In this model, the Big Bang isn't a one-time event but part of an eternal rhythm where universes expand, collapse, and then regenerate in a new cycle. This theory suggests that our universe could have been reborn from the remnants of a previous one. The process of contraction and expansion in a cyclic pattern would mean there was never a true beginning, but rather an eternal series of universes emerging, evolving, and renewing themselves endlessly. Cyclic cosmology raises profound questions about the nature of time, suggesting that time itself might be cyclic rather than linear. If this theory is correct, it could mean that what existed before the Big Bang was simply another version of the universe, one that collapsed only to give birth to our current cosmos. Conceived, this hypothesis offers a tempting possibility: distinguishing gravitational waves that could act as fingerprints of a pre-Big Bang universe. As we continue to investigate what might have existed before the enormous detonation, we delve into ideas that push the limits of our understanding, challenging even our most basic assumptions about space, time, and existence itself. Perhaps one of the most marvelous ideas comes from the domain of quantum gravity, a field that seeks to combine quantum mechanics with general relativity. This consolidation could potentially reveal a unified theory of everything and offer insights into what existed before the Big Bang. Quantum gravity suggests that space and time are not smooth, continuous elements as we experience them, but rather intricate, granular structures. This hypothesis posits that the fabric of spacetime itself may have been formed from a minuscule, Planck-scale structure, with tiny quantum fluctuations shaping the universe in ways we cannot yet fully fathom. In this view, what we perceive as the smooth continuum of spacetime would have only emerged from these fluctuating quantum fields. Hence, the before the Big Bang could be described by a completely different realm of reality, one where space and time themselves were not fully formed. Another possibility is that the universe is part of a vast cosmic landscape of potential universes, each with different physical laws and constants. This hypothesis, known as the string landscape, arises from string theory, which proposes that all fundamental particles are actually tiny, vibrating strings. In this framework, there are numerous possible configurations of these strings, each corresponding to a different set of physical laws. The string landscape could imply that our universe is just one of many, each arising from its own distinct Big Bang-like event. The existence of such a landscape also introduces the idea that other universes might have different dimensions, varying strengths of gravity, or even entirely different types of matter. In this view, our universe might not be unique but rather part of a multiverse, a collection of universes, each evolving independently. The multiverse hypothesis provides a speculative yet fascinating answer to the question of what preceded the Big Bang. Another universe, in a different configuration, potentially leading to endless cycles of creation and destruction with no definitive beginning. In addition to these cosmological models, some theoretical physicists have also considered the role of black holes in shaping the nature of the universe. A theory gaining attention is that our universe could be the result of a black hole formed in another universe. In this scenario, the singularity at the center of a black hole could serve as a gateway to another universe, with a Big Bang representing the moment when such a black hole birthed our universe. This theory is supported by the fact that, according to general relativity, the singularity at the center of a black hole is a region where spacetime curves infinitely, causing the known laws of physics to break down. It is possible that the extreme conditions inside black holes could lead to the creation of new universes, suggesting that what we consider the Big Bang might have been the birth of our universe from the singularity of an ancient black hole. Exploring these ideas requires a deep dive into the very concept of time itself. Some cosmologists speculate that time, as we understand it, may have had no meaning before the Big Bang. If time began with the Big Bang, there may have been no before in any conventional sense. According to this view, time itself would have emerged from a quantum transition or from a primordial state where the usual distinctions between past, present, and future did not apply. This could lead us to rethink the concept of causality, which relies on the assumption that events occur in a linear sequence. If time did not exist in the way we experience it, then the question of what came before the Big Bang becomes meaningless, as there would be no temporal framework to support it. Further complicating the picture are theories of cyclic time. As mentioned earlier, cyclic cosmology proposes that the universe undergoes infinite cycles of birth, evolution, and eventual collapse. In this model, the Big Bang could represent just the latest bounce in an eternal series of universe cycles. These cycles might not be identical but could evolve differently each time, each with unique physical properties. The cycle of the universe, according to this hypothesis, would be a continuous process with no clear beginning or end, rendering the question of, before the Big Bang, irrelevant in the traditional sense. The idea that time itself might be cyclical suggests that each Big Bang could be followed by a contraction and another big crunch, with the universe reinitiating itself in an endless loop. Another avenue of exploration into the nature of the universe is the potential for a primordial soup of particles and fields that existed before the formation of stars and galaxies. This concept suggests that before the universe began its rapid expansion, it was filled with a dense and hot mixture of elementary particles, including quarks, leptons, and bosons, in a state of extreme energy. These particles would have been interacting at very high temperatures and densities, laying the foundation for the formation of matter and energy as the universe cooled. Some versions of this hypothesis propose that this primordial soup existed in a quantum foam, where particles constantly appeared and disappeared due to the uncertainty principle of quantum mechanics. The properties of this soup could potentially offer insights into the universe's earliest moments and, consequently, what preceded the Big Bang itself. Ultimately, what existed before the Big Bang remains one of the most profound mysteries in science. As our understanding of quantum mechanics, cosmology, and fundamental physics expands, new theories will continue to emerge, offering increasingly complex, and sometimes perplexing, explanations for the origins of our universe. While we may never fully grasp what came before the Big Bang, the pursuit of this knowledge will continue to push the boundaries of human curiosity, driving us to explore the unknown frontiers of existence.